Hello friends, welcome to BSS Studies. I am Vara. Today I will explain about law of conservation of momentum. So we already learnt about momentum. So here what is momentum? Momentum means the product of mass and velocity. Product of mass and velocity is known as momentum. So momentum is represented by P bar. Okay. So momentum is represented by P bar. P bar means this is a vector quantity. Vector quantity. So here if we see mathematical formula of momentum mf. So if you see P bar is equals to mass into velocity. So this is the mathematical formula for momentum. Okay. So if you see I am taking this triangle like this and here P bar which is equals to mv bar. Okay, so if you see I want P bar which means mass into velocity. I want mass which means momentum by velocity, and if I want velocity, momentum by mass. Okay, so this is the triangle which is useful. So if you see units are SI unit kg meter per second, because the SI unit of mass kg, SI unit of velocity meter per second. Okay, and if you see CGS gram centimeter per second, gram centimeter per second. Here this kilometer kg meter per second is also written as Newton second. Here this is dyne second. Dyne second. Why means here why Newton second means, so Newtons means kg meter per second square into a second. Okay, so 1 second gets cancelled and the remaining is this. Okay, so if you see dyne second means gram centimeter per second square into second, and here 1 second is cancelled and the remaining is gram centimeter per second. Okay, so these are the two units and this is the formula, mathematical formula, which is very useful to calculate the problems on momentum. Okay. And if you see change in momentum, here change in momentum is nothing but here we have to take initial velocity which is nothing but Vi or U. Okay, so V initial or U. Here final velocity Vf or V. Okay, so there is a one body which is mass m. Okay, so take three quantities. So here change in momentum means mass into final velocity minus initial velocity. Okay, so this is the change in momentum. So if you substitute m into final velocity Vf minus initial velocity Vi, which is nothing but mvf minus mvi, which is also known as mv minus mu. Okay, so this is the change in momentum. Okay, so if u is 0 and the final is mv, because here this term will become 0 because m into 0. mv. Okay, so the remaining term is mv. Okay, so if I take rate of change of momentum means m into v minus u by time. Rate of change of momentum means we have to divide with how many seconds or how much time. So if you see, if I divide with the t, here I am writing like this. See, mass into v minus u by t. Here v minus u by t is written as mass into acceleration. Okay, so this is what is the formula of this? Force. This is the formula of force. Here we can say that the rate of change in momentum is here, right? Rate of change in momentum is equals to force, which is nothing but mass into acceleration. Okay, so this is the change in momentum and the rate of change in momentum. Okay. So here law of conservation of momentum means, so if I take one body like this and it is moving with u, and another object, this is m1, this is m2, and this is moving with v velocity. Okay, so if you see, these are collided at one point. Here this is the point before collision. Before collision, this is the point, and after collision, this is also a point. Okay, so this point they will meet and collide. Okay, so if you see here, law of conservation of momentum means total momentum is constant. Total momentum is constant, which means, so if I write the final initial of these two bodies, which means mu1, m1 u1. Here take u1 u2. Okay, so m1 u1 plus m2 u2. Okay, so which is equals to, after this is m1 moving with v1 and this is m2 moving with v2 at some other directions. Okay, so here this is m1 v1 plus m2 v2. So this is the total momentum. Okay, so if you see here, if I take u1 and u2 are equal and these are in rest. Here u1 and u2 are equal and these are in rest. So if I take this whole term will become 0. Okay, so 0 is equals to m1 v1 plus m2 v2. So here I am taking v1 is equals to v2 because here one condition is mentioned. m1 is greater than m2, which means this body is greater than this according to mass. So if I take after collision, both are in same direction like this. Okay, so after collision both travel towards this direction only. So these two bodies velocities are same because this have same mass, bigger mass than this. So it is attached to this and goes towards this direction. Okay, so here I am transposing this term to this side, which means minus m1 v1 is equals to m2 v2. Okay, so if I take these two are cancelled. Okay, so these two are cancelled because both velocities are same. So both velocities are same means after collision both masses are also same. Okay, so this is exactly wrong. Okay, so this is exactly wrong because I will say here if we see, here we should not take velocities are equal because here this body have u1 and u2. Here this body have u2, u1 and this body have here v1 because here both are before collision like this and after collision like this. Here this body have bigger mass and this body also have bigger mass. So if you see after collision, after some time both are traveled own directions. So here I am taking v1 is greater than v2. So here if I take minus m1 v1 is equals to m2 v2. So this is one of the formula. Okay. So note down. So if I take here v1 is equals to v2, this is one of the case. If these bodies are not in rest. Okay. So if I take m1 u1 plus m2 u2 is equals to m1. Here the both velocities are equal. So here I am taking x. So m1 x plus m2 x. Okay. So here m1 u1 plus m2 u2 is equals to, if I take this term as common, so x into m1 plus m2. Okay, so if I transpose this term to this side, x is equals to m1 u1 plus m2 u2 by m1 plus m2. So this is the common velocity. Here this is the common velocity of these two bodies after collision. Okay, so this is the formula for Vcom. So if both are traveled in this direction, both are traveled in same direction means positive. Here this is positive. Here this is positive if both are in travel in same direction, and if both are traveled in opposite direction. Both are traveled in opposite direction means m1 u1 minus m2 u2 by m1 plus m2. Here how this is minus means here before case we take opposite directions. So like this, if we take, the formula is this. Okay. So this is the velocity, common velocity, and we will do some problems in next video.